Hey everybody, so I have some really cool and really exciting news for you today. As we all know, life exists on the surface of the Earth. Life exists in the air, flying around or being carried by the wind. Life exists in the oceans, swimming around or being pushed along by the currents. Life even exists deep in the ground, not just in the soil, but deep in the bedrock, far away from any sunlight and atmospheric gases. But until recently, scientists didn't really know just how deep into the ground life could persist. After all, the deeper you go into the crust, the hotter it gets. The pressure gets higher and higher. The gases used by most organisms to breathe are no longer available. Water becomes increasingly difficult to come by. And the temperature is just crazy hot, way too hot for the vast majority of organisms to be able to tolerate. This is why the recent discovery is so incredible. For a long time, scientists have been trying to determine how deep life can exist. But every time they dig deeper, they keep finding more life. We can't seem to find a lower bound, or we haven't found one so far. Researchers at the Deep Carbon Observatory are now reporting that they've identified a, quote, deep biosphere that runs as deep as 5 kilometers under the surface, and includes over 2 billion cubic kilometers of subterranean biome, with anywhere from 15 to 23 billion tons of biomass in the form of small worms and various microbes. Okay, so that's already pretty remarkable, but the strange nature of the organisms that they've discovered are even weirder and more incredible. To paraphrase the report from the Deep Carbon Observatory, they've described this deep biosphere as a, quote, subterranean Galapagos, unquote. It includes bacteria, archaea, and eukaryotic life forms of breathtaking variety. The scientists estimate that up to 70% of all bacteria and archaea on the planet could be found in this deep biosphere, with the majority of them numbering perhaps in the millions of species being undiscovered and undescribed. They've only analyzed a small fraction of these species so far, but the genetic diversity that they've seen already is just bewildering. These discoveries are really cool, but they bring our attention to new mysteries. For example, how do individual organisms move around in such an environment? The only open spaces are cracks in the rocks. And for that matter, how do populations move? Because scientists have seen some of the same bacterial species on opposite sides of the planet. It's really strange that not only do you have this wild biodiversity, but you're also seeing the same species separated by huge geographic distances. And so the obvious question is, how? How does this happen? The scientists want to know how deep life can be, quote, so similar in South Africa and Seattle, Washington, unquote. The scientists also want to know how geological processes like volcanism, earthquakes, and plate tectonics can influence the deep biosphere. Another functional question deals with energy. There's obviously no sunlight 5 kilometers below the Earth's surface, so how do these life forms get energy? Do they use hydrogen or methane? Maybe they use some kind of process that captures energy from the radioactive decay of elements like uranium. There's a lot of mysteries about the ecology of the deep biosphere and how it affects life on the surface. Researchers don't have enough hard data to quantify the effects of the deep biosphere, but it is understood that this life may have some role to play in geological processes. For example, subterranean microbes can help to purify aquifers as they extract CO2 and other compounds containing carbon or sulfur or nitrogen from the water. When super deep boreholes were injected with CO2, it stimulated so much growth that the boreholes became clogged with biological muck. The microbes responded so vigorously to the huge influx of nutrients, the relatively huge influx of nutrients, because remember, they're kilometers below the surface where there's barely any CO2 at all. So if you inject a whole bunch of CO2, it's like dropping powdered iron in the ocean. You'll cause a giant algal bloom. So when they injected CO2 into these boreholes, It caused all of these subterranean microbes to just go crazy. Their populations exploded until they filled the bottom of the borehole with a huge, slimy mess. Now, the deepest question, no pun intended, is how did this life get here? The fundamental mystery is whether life originated near the surface and moved down into the crust, or if the first life actually emerged somewhere deep under the surface, and then crawled up and eventually became exposed to the oceans and the dry terrestrial surface. One of the weirdest mysteries, in my opinion, is how these organisms reproduce, and how they manage their life cycles. On the surface, life tends to move pretty quickly, responding to rapid cycles like the rising and the setting of the sun, or the rotation of the moon. Life cycles are measured in days, or years, or decades, and organisms reproduce vigorously and rapidly almost whenever they can. But in the deep biosphere, life moves at a different pace, with some of these microbes living for over 1,000 years without reproducing. Researchers describe how life in the deep biosphere doesn't live at a fast-paced rhythm like life on the surface. Because of the harsh conditions and the lack of energy, this deep life operates on a much slower rhythm. Karen Lloyd is an associate professor at the University of Tennessee, and she said, quote, "The strangest thing for me is that some organisms can exist for millennia. They are metabolically active, but in stasis, with less energy than we thought possible of supporting life." Unquote. Rick Caldwell is a microbiologist at Oregon State University, and he said, quote, "We humans orientate towards relatively rapid processes, diurnal cycles based on the sun, or lunar cycles based on the moon. But these organisms are part of slow, persistent cycles on geological timescales." Unquote. This discovery of the deep biosphere doesn't just radically expand our understanding of life on Earth. It radically expands our expectation for life on other planets, elsewhere in the cosmos. At first, we didn't know that life could live in these conditions, and now we do. So we can't rule out a deep biosphere on other planets, even on planets that might have surface conditions that are totally inhospitable to life. Robert Hazen is a mineralogist at the Carnegie Institution for Science, and he said, quote, "We must ask ourselves, if life on Earth can be this different from what experience has led us to expect, then what strangeness might await as we probe for life on other worlds?" Unquote.